Okay, now after we make sure it met the assumption, then we can start the test itself. It's like after we have a partner and we met all the conditions, we think, yeah, I mean, it's time for us to get married, jump into the test, right? It's time to get married and test our relationship, our marriage. Yeah. So there are 5 steps of hypothesis testing. Now your book again, your book is, I think, in the book says 6, but I just give you 5. Okay. The first step is making the assumptions. In other words, we need to review those assumptions. Remember the 5 conditions, the 5 assumptions. Um, we need to examine if our data meet those assumptions. So let me give you an example. If we gather data from 100 people asking their opinions about abortion, from 1 to 9, how much do you agree with legalizing abortion? And then we compare gender differences, men versus women. Now, let's examine those 5 assumptions. The first is the assumption interval or ratio scale of measurement met. Um, it is. The clue is right here. From 1 to 9, this is our interval scale, so it's met. Now, the second one is the participants are randomly selected. We can pretty much just say no, it's not met because in psychology we just pretty much never met the data, met this assumption. Is it normally distributed data? We need to be exactly sure, we need to see the data, the raw score. However, I think it's in your book. It says if you have more than 30 people, 30 data points, probably you are confident it probably is normally distributed. Some people are more conservative. They say it has to be like 50 people. Well, anyhow, we have 100, so I guess it's normally distributed data. Alright, so we can assume a normal distribution is made. Is it independent? Well, probably. I mean, hopefully it is. We have them answer anonymously, so they will not influence each other's answer. Finally, homogeneity of variance. We have to look at data to be sure, but usually we just assume it's met. Okay, so that's first, making assumptions. It's those assumptions are not seriously violated, so we can go ahead and move on. So the second step is stating the research and null hypothesis and selecting setting the alpha level. Alpha level means the level of significance. Now, we always use 0.05, right? 5%, because Ronald Fisher, I discussed about this before already. But actually, theoretically, researchers select the alpha level themselves. So you don't really have to adopt this 5% thing. You can say, oh, I want 10%, a little bit more lenient. Or you want to be very strict. You say, no, I want to be 1%, only 1%. Yeah. So before the research, you set your own alpha level. But just so you know, pretty much everybody just adopt this 5%. So first is stating the research and null hypothesis. So in our case, we study the gender difference in the opinion of legalizing abortion. What is the research hypothesis? The symbolic notation will be hypothesis 1, H1. That's our research hypothesis. Is a mu1. Mu, remember, is the population mean. The first one, first population mean, does not equal mu2, the second population mean. And what will be the null hypothesis? This notation is 0, right? Because it's null, no, it's 0. So both populations are equal. Mu1 equals mu2. Now select alpha level. Yeah, just say 0.05. Everybody say 0.05. Just say 0.05. All right. So that's the second step. However, there's one thing we need to discuss. Do we know the direction? And what do I mean by direction? So in this case, do we know which gender will probably be more likely to support legalizing abortion, pro-choice? If we know then that means that we know the direction where it is heading to. If we don't know, then it's non-directional. So let me show you this distribution. Now, assuming this distribution is a woman's distribution, that's their opinion, right? Now, to compare men's distribution, the mean scores has to be very, very far away from the mean, either this way or this way, right? So if the score is very different from a woman's score, then the women's score enter the critical region, what we say. Critical region, either this here or this here. And remember, we say we want to be sure that 5% less that this is actually just a coincidence. If men's scores is right here, then we have reason to believe that either we get a very extreme men, men with very extreme opinions are different from women, or actually men are from different populations, right? Now, remember this is 5%. In this 5%, we don't know which direction, either this way or this way. So we need to split this 5% in half. So this critical region cover the one end with 2.5%, and this end cover 2.5%. So we cover the both in total 5%, right? So that's if that's the case, we call it two-tailed test. And as you can see, two tails is a little bit more strict. The scores has to be very different because I see those areas are quite small. It has to be really different in order to enter this area. It's different from one tail. Suppose we already know, suppose a men are in this direction. We know, we assume men is in this direction already. We don't even consider this direction. Then we can put all the 5% right here. And this becomes more lenient. The mean doesn't have to be so way different in order for us to say they are significant. Yeah. So this is a one-tail test versus a two-tail test. Suppose past research suggests that women in general are more likely to be pro-choice. Okay, so we have evidence to suggest that women probably are more likely to agree with legalizing abortion. If that is the case, then this kind of suggests that this one direction. And we can use one-tail test. Now, as I said, the one-tail test is more lenient. But the catch is this. If, in any case, the result happens to be going this way instead of this way, then you cannot claim it's significant. It's kind of like a gamble, right? If you bet you put all your money on this end, and it turns out on this end, then you cannot say, "Oh, I won," because it's very extreme. No, you cannot say that. You lose, right? So there's some risk in one-tail test. So unless you are sure, you don't want to bet on this, just one direction. Okay. And for the research, hypothesis symbolic notation will be like this: mu1 bigger than mu2. You are indicating in the direction. And null hypothesis will be mu1 less or equal than mu2. That means even if it is less and very, very less, very extreme on this side, you still cannot say it's significant. So one-tailed versus two-tailed. One-tailed is that when you have a good research evidence to believe it's directional. Directional, again, that means you already know which direction it is leading to. You assume women are more likely to agree, right? And if it's two-tailed, then it's non-directional. That means I don't know. Which one will be, which gender will be more or less. As I said, one-tailed is easier to reject null, find a significant result. Okay. Some people, however, they believe that it doesn't matter what kind of condition, any situation, we always need to use two tails because two tails are more strict. Yeah, this is kind of like cheating. Yeah. So it depends on different researchers of philosophies. I've seen a lot of publication works they use one tail. Okay, just so you know. Step 3 is specifying the test statistics. If we compare means of two populations, we use the T or Z. We will discuss about this later. Actually, the next step, we are going to talk about Z test. Excuse me. And if a correlation, we use a Pearson correlation. And there are many, many more. But you don't have to worry about it at this point. Okay, step number 4 is computing the test statistics. So we're going to tell you how to do that. And then step 5 is making a decision interpreting the result. Either you reject the null because a piece is less than 0.05, right? Or you fail to reject the null. Yeah. And then you need to specifically interpret the result. Okay, you have to remember interpret the result. So for example, you can say women agree with the pro-choice significantly more than men do. If you see the mean is more than men. The mean from women is more than men's mean. Okay. Then we're going to talk about Z-test, but cover it later.